Let's continue to learn about intersection and union of sets. The intersection of two sets, A and B, symbolized by A and B, is the set of all elements that are in both sets. In set builder notation, we express it in this way. We say A and B equals the set of all the elements of X such that X belongs to A and X also has to belongs to B, and close braces. So again, A and B is the set with all the elements X such that X belongs to A and X has to belong to B at the same time. So take this for example. We have a set that has 10, 12, 14, and 15, which is this red set, which is this red circle. That's not bad. Right there, red circle there, okay? We also have another set, B, that has 13, 14, 15, 16, and 17. And notice the blue there starts with there, and let's see if I can do as good a job. Oops, not as good as the other one. Better. Okay, notice that they overlap in here because the number or the elements 14 and 15 are both in set A and set B. So they overlap, they intersect. Literally, it's like the intersection of roads. So in this case, we write A and B, which is the intersection, has two elements, 14 and 15. And that expresses, this is the set builder notation way of expressing this shaded area, which has two elements. Notice that the elements of A are placed inside, right? It's inside the circle for set A. And also, the elements of B are inside the circle for set B. The elements intersection are placed into the portion where the circles overlap. So the way we write it is A and B is the shaded portion. So intersection is an example of a set operation. It's a rule for combining two or more sets to form a new set. So if you recall at the beginning of this chapter, we explored a little bit of the approach of using Venn diagram to express our ethnicity and races. And that's the concept of different sets, right? And some races and ethnicities overlap. The intersection of three or more sets consists of the set of elements that are in every single set. Notice that the word and is sometimes used to indicate intersection. A and B is the set of elements in A and in B. So let's look at how it's used in mathematical operations first. Let's find the intersections. We've got a couple of sets. There's A that has 5, 10, 15, 20, 25. B has 0, 10, 20, 30, 40. And C has 30, 50, 70, 90. And we have to find A where A and B overlap. So what I like to do is I like to list them out. 10, 15, 20, 25. Be careful, my 5 sometimes looks like 3s. And then I write out the B's, but I make sure that I try to overlap them. 20 here, so I don't have 15, I have 20. I don't have 25, but I have 30, I have 40, right? And then if I do same thing with C, I can do all empty to 30. I don't have 40. I have 50. I have 70. I have 90. If you do it on your sheet of paper, you can write them out horizontally. That looks much nicer. If I have to look at A and B right now, and what do we have in common here? I see 10, I see 20, that's it. So the way I finish this problem, it's just that. I write out, use the list method, write them out, 10 and 20. And if I look at B and C, I have 30 in common, I don't have 40. I think that's it. B and C, I'll use the red ink, it's just 30. And now if I have to look at A and C, I look at A stops at 25 and C doesn't start until 30. So there's nothing in common. I can either write it with an empty set like that, or I can just simply say it's a null set. Okay? So that's, I like to lay them out, list them out, and so that I can see who and who overlaps. Again, make sure that you give it a try for the example that's provided behind this before we move on to this slide. When the intersection of two sets is the empty set, like the last example we just did, the set are said to be disjoint. D-I-S-J-O-I-N-T. So, for example, the students who stop attending classes midway through a term, and the set of students earning A's are disjoint. If you don't come to class 50% of the time, there's no way you can get an A, right? You cannot be in both sets at the same time. You cannot get an A and by not coming to class. Even Mark Zuckerberg did come to class when he was attending Harvard. The Venn diagram for a pair of disjoint sets A and B is right here at the bottom, right here. Notice that there's no overlap between A and B, right? And that's when we know that they have nothing in common. So they have no elements in common, and they don't overlap at all. And if we have to write it, we would say A and B equals null set. And so that's intersection. There's another way, if we look back at our previous example, there's another way of combining sets to form a new set, and that's called union. Union, in my opinion, is relatively easier. Literally, just add these two sets together, and it's also using the symbol U, so it's all consistent. And so we say that the union of two sets A and B symbolized by A union B is the set of all elements that are either in set A or in set B, or both. So in set builder notation, this is how we write them. A union B is the set of all the elements X such that X belongs to A or X belongs to B. That's how we say it. So it's an or. You know, the way some people say the shape of the U is like a canoe, like an oar. That's how they relate it to this one. If that helps you, that's fine. For me, the way I remember them is, actually, we don't need this diagram. I just noticed that the way I remember them is literally I have a picture. Whenever I see union, I see two people joining. I see two circles joining together, and everything that's in there has to be counted for. And that picture works for me. So you can use whatever method that works for you. So let's look at the previous example with the previous chart. It says that A has 5, 10, 15, 20, and B has 5, 20, 30, and 45. In this case, like I said, you just put all of them together. So in A union B should have 5, 10, and order doesn't even matter. I list them out from the minimum to the maximum, but you don't have to. 30, oops, that's a 3, and 45. That's 30, 45. That, I think I got everybody, right? So also notice that 5 and 20 are in both sets, but we only list them once. If you want to repeat them, that's totally permitted, but you list them once, it's in there already. And also notice that the A, this time, A union B is the shaded, and the shaded is this whole part here. I should use black, different color. This whole part here, right, is this thing. Maybe I'll shade it. Last time when we shaded it, we only shaded the intersection. This time we're shading both circles, right? So it's the shaded area consisting of all elements in either set. So all the elements on the left-hand side A circle and or on the right-hand side B circle are included in this figure. So let's do some examples. We have 3 sets, and we need to find the unions of the 3. And literally, like I said, you just put everything together, and that's how easy this is. So write out all the A's, and if you want to list them like I did before, that's fine. But sometimes I just write down the first one. Okay, then I go to the second one. I already have a 2. I already have a 4. I don't have a 6. I don't have an 8. I don't have a 10. I just simply add it in. That's my A union B. A union C, same way. I'm writing out all the A's. Now I go into the C. C, I already have a 1. I already have a 3. I already have a 5. I don't have 7. I just add the 7 in. And B union C. B, I have 2, 4, 6, 8, 10. Now I don't have 1, so I add the 1 in. I don't have 3. I don't have 5. I don't have 7. Remember, order doesn't matter. Repetition doesn't matter. This is perfectly fine, right? So in my opinion, union is a lot easier than intersection. So make sure that you are comfortable with this. So that's the second video for this unit, and there should be one more video before we move on to some practices, but I want to make sure that you are 100% comfortable with intersection and unions, and you're also 100% comfortable with the differences between the two, and make sure you're able to explain it before we move on to something that's slightly more complicated.